Okay, so these are two integration problems, which is what we covered in 5.1 and 5.2. These two problems actually use two slightly different techniques. One of them requires substitution and one of them does not. So let's look at the first one first. Makes sense, huh? Yeah, look at the first one first. Number one. So does anybody want to share what they tried on this one, or what a step one was? Anything you notice about this one?
I try to find well, you.
Okay, so you tried to do substitution on this one. I'll
Yeah.
give
But
you
we
a
don't,
hint. I'll give you a hint on this one. Anytime you have just a single X in there, you're probably not going to be doing substitution. Okay, so I can see why you thought this one would be substitution because it's kind of funny looking. It's not just a straight up like 3x squared or something like that. But on this one, rather than substitution, what we want to do is we want to rewrite this. So remember, this is a technique that we used with derivatives too. We want to leave that 3 alone and take that x to the 2/3 out of the denominator by making its exponent negative. Okay, so that's going to be one of the things we want to kind of practice on the test. The ones where you need substitution and the ones where you don't need substitution are mixed together. They're not labeled separately. So we want to make sure we have some techniques to be able to determine which we need to do. And one of the hints on this one was that we had an x here, but there weren't any other x's in the function. Okay, so once we rewrite it, then we just need to apply our integration rules. So that 3 coefficient, I'm going to leave it alone, just 3 times. I'm going to take my exponent and add 1. So negative 2/3 plus 1. And again, you can do that on your calculator if you're not comfortable. But that becomes positive 1/3. And then we have to remember to either divide by the exponent or multiply by the reciprocal of the exponent. So we're going to have an extra 3 in there that came from taking the reciprocal of this new exponent. And then don't forget, we always have that plus c at the end. So we do just want to do a little bit of simplifying. We can take this 3 times 3 and turn that into 9. So that would be our final answer for number 1. So once you see the trick, it's a pretty easy problem, but I can see maybe starting out you didn't, if you don't recognize that right away, then it's kind of tricky.
Okay. I did, well, when I saw, I did change it to the format where 3x to the, and then bring that, the power up where like negative 2/3. But I guess I just didn't do it correctly, that's all.
Yeah. Well, that's good. You got step 1, and that's why we're practicing to figure these out, because they do take some time because they're new. Okay, the second one, this is one where we do want to use substitution. And one of the hints here is because we have this sort of inside function is what I keep calling it, but we have some entire expression raised to the 4th power. So that's what we're going to set up to be u. And then when we're doing substitution, the next step is to take the derivative of u. And then we take that dx and we multiply both sides by dx so we can move it over to the other side. The idea is that we want to solve for du. So we have this. Okay, once you have du by itself, that's where you want to go back and look at your original problem and kind of evaluate where we are, if we need to do anything else to the du, if we're ready just to do the substitution. So this is where I would do step 4, and I would start writing out my substitution. So this part in the middle, x squared plus 7 raised to the 4th power. Well, we said x squared plus 7 is equivalent to u, so I'm going to replace that just with u to the 4th power. What I have left then is my x and my dx. That does not match what I have down here right now for my du. X dx, I have 2x dx, so I want to get rid of that 2 so that I do match exactly what's up in the yellow. And again, I always like to rewrite this. Someone asked, do I have to? You don't have to, but to me it's easier to have that du separate because of what we're going to do in our future steps. So this now, the right-hand side matches exactly what I have highlighted in yellow up in my problem. So now I'm ready to do the substitution. The x and the dx get replaced by 1/2 du. And I still have my squiggle in the front because I haven't changed any exponents yet. So this was the blue and this was the yellow in our original. And then I like to just bring that 1/2 out front out of the way so I can just do my integration. So that step is really just a rewrite. You don't have to do it that way. And then we're ready to do the integration. So we're ready to actually change the exponent. Don't forget u to the 5th because we add 1 to the exponent and then we multiply by the reciprocal of that exponent. And then we always have our plus c at the end. We can combine these two factors in front. So that's equivalent to 1/10 u to the 5th plus c. We don't want our final answer to have u's in it. We want to go back to our x's. So we do our back substitution. U is equivalent to x squared plus 7. That is still raised to the 5th power plus our constant. That would be our final answer for number 2. Any questions along the way there?
I have a question. So when you were talking about separating the 1/2 from the du, I was wondering, could you, instead of dividing 2, could you times both sides by 1/2?
Absolutely.
Separate? That's
Absolutely.
Okay.
Those are equivalent operations. So dividing by a number or multiplying by its reciprocal, those are equivalent. So yes, if it makes more sense to you to think about this step, okay, we know we need to get rid of that 2. So another way to do that is to multiply both sides by 1/2. And then you already have this sort of in the form that maybe I like it to be in, if you like it to be in too.
Okay.
And then the 2 and the 1/2 cancel and you have your x dx. Yes, you can think of it like that also. Good point. Any other questions or comments? Okay. Well, before we get started on material today, I did just want to kind of take a look in Ivy Learn and kind of see where we are and make sure everybody's caught up on the calendar and everything like that. So let me bring this into view, share it with you guys. Okay, so here's where we are. It is the 20th, so we are in week 13. This week today, we are going to do section 5.3, which is a little bit more on integrals. Your homework then would be the WebAssign for section 5.3 and that worksheet packet. Those are both coming due on the 25th. Okay, is that Saturday, Friday or Saturday? I think Saturday. So make sure you are working on those and finishing those up. That'll be the last homework we have before our exam. On Wednesday, we are going to, it says new material here. There isn't really any new material. Wednesday is going to be reviewing for the test. So one of the things I added to Ivy Learn here last week is this test 3 topics. I can pull that up real quick, I guess. Take a look. So this it doesn't give all the content for every section, but it just kind of gives you bullet points just to refresh your memory of what we worked on in every section. The other thing that I added in here is you can see section 3.1 graphing. There is one question that comes from that section. Sections 4.1 and 4.2 on the test, there are 2 questions from that section. So I put how many questions come from each section. One of the things that's kind of tricky is down here in section 5.3, it says there are 3 questions from this section, but one of those questions is really sort of also a 5.2 question because in section 5.3, we will be using substitution also. So there is some kind of overlap between the sections, but that at least gives you a rough guideline of everything you'll see on the test. There's the review sheet. It's on the front page too under reviews, but I linked it right here if you need it. One thing I did want to note and this is a change since our paper and pencil test on the review. It's opening right now. This first question says, note, the x-intercepts will not be emphasized on the exam. The relative extrema and reflection points will be. So there's a little change there. The WebAssign test does ask you to find the x-intercepts, but I want you to know that they are able to be found by factoring. There's not any quadratic formula or crazy techniques that you need to find the x-intercepts. Some of these problems on the review sheet, some of these right here, finding the x-intercepts is a little tricky maybe, and the test finding the x-intercepts are straightforward, but you will need to find the x-intercepts on the test. That's just one little change. Okay, so I'm not going to collect this review sheet this time, but please, please, please do the review sheet. Practice those problems, write them out completely and thoroughly so that you have good notes for you when you take your exam.
Sensley,
Yes.
are you gonna are you also gonna do your own, like, post your own works, like?
I'm hesitant to do that this time, Nadia, because if you print that out, you have the answer sheet for the test, kind of. What I would like for you to do is to try working these problems on your own and then come to me with questions. And I will work through any of them with you that you have questions, but I don't really just want to post the whole solution set.
Okay.
Okay, but I'm happy to work through as many as you need to, okay?
Okay, thank you.
Any other questions?
I have a question for packet 3.
Yes.
The due date, I saw that there one said for the 25th and one said for the 22nd, both at midnight. So I was confused as to which.
Oh, I see that. Look at that, Daffodil. Right here, it says the 22nd. Yes, I believe it is the 25th. That is a mistake.
Okay, because I was confused.
Yeah, so the worksheet packet, I am going to grade the worksheet packets on my computer and send back the notes to you. So if you finish it sooner than the 25th, I can give you feedback sooner than the 25th. That would be great, but it's not due until the 25th. Yes, you're right. There's a typo there, and I will fix that.
All right, thank you.
Any other questions?
So did you say that if we submit before the 25th, we can fix our mistakes? Is that?
I didn't say that. I said you'll get your feedback sooner if you submit it. But no, it's if you have questions about it, contact me before the 25th. I'll work through problems with you. But no, there's just not enough turnaround time for me to give feedback and then you turn it back in and back and forth.
Okay.
So yeah, take the full time if you need it. Other questions?
Excuse me.
Yes, Merritt.
Is that the test was timer?
I'm sorry, say that again, Merritt?
It's a test, has a timer.
The test does have a timer. And that's one of the things we are going to do together on Wednesday is do a practice test. Let me show you kind of how that's going to work. I'm going to bring WebAssign into our share just a second. So we don't need success tips. So you'll see right here, practice for exam experience. If you guys click on that now and try to do it, you can't see that yet because that's how the test is set up. There's a password. So in class on Wednesday, I will give you the password. You'll go in and take this little practice test, and then you'll submit your work in Ivy Learn. And then once you've done all that, you'll get full credit for that day. Okay, that'll be our participation, our instructor choice points for that day, because I want us all to be able to practice this together before it's test day and you guys are freaking out on me because something's not working right. Okay, so we're gonna have a whole practice exam experience on Wednesday. And hopefully that will answer any questions you have and we'll be able to, you know, fix any glitches or work out any issues that anybody's having.
Do we have to submit work afterwards for the practice one?
Yes, because I want you to have practice with that as well. Yeah, yeah. So it's going to be the whole thing. So once I give you the password, you'll type it in, you'll get to see the problems. You'll have some notebook paper next to you where you are neatly labeling your problems and showing your work. And then once you submit the test in WebAssign, you will go to Ivy Learn. And if you go to our homepage and scroll down a little bit, right here, it says click here to upload assignments. That's where you will upload your work. And there's some directions there if you need them, some tips for how to upload an assignment. And right here, here is upload your practice exam work. Notice it must be uploaded within 30 minutes of finishing the test. The test has a time limit on it, and you cannot keep working on your scratch paper after this. The 30 minutes is just if you're having any technical difficulties or if it just takes you a few minutes to scan it or whatever. But the idea is that you finish the test according to that time limit, and then these 30 minutes are just a little grace time to give you time to get it uploaded.
Okay.
Other questions?
And the test that's gonna be on 27, right?
Yes, the test itself is next week on Monday. Is that the 27th? Let's look.
It has a like a time to take the test, or it's open all day.
No, we'll
is
take
that-
it during class time together. Just like you come to Zoom class,
Yeah.
you'll come to class on Monday. Let me open it. And I'll type some of these directions in because I don't think I have it written out yet. I just wrote test 3. Yeah, it's on Monday. You will show up to Zoom just like normal. I will give you guys the password. I will stay here in our Zoom session, but you may leave and go do your test. I'm going to stay here because if you get into any trouble or have any issues, you can come right back into our class and ask me about those.
Okay.
Okay. I'm also going to post, I don't have it on here yet, but I'm also going to post my cell phone number so that you guys can reach me immediately. I don't want you to feel uncomfortable or nervous about the logistics of it. I'm going to give you 2 different ways to contact me so that I can make sure everything's okay while you're taking the test.
Miss Ansley,
Uh-huh.
so it's on WebAssign, you said?
Yes.
Okay.
Yep. Yep. It'll show up just like this. It doesn't show up yet, but it will show up just like this practice exam. It will be one of your assignments that's going to pop in here, and you'll have to type in a password, and then it'll look similar to your WebAssign homework. You need to make sure you are writing out the problems on your scratch paper though.
Okay.
Okay. What you don't have to do, let me go into 5.2 because we can see that one right now. You do not have to copy down all this information here at the top. Do not waste your time copying down the instructions or anything like that. Just the problem part, just where you would show your work, what you're doing.
Just like when we used to do our homework
Yes,
assignments?
yes,
Okay.
yeah. I just need to see your steps, basically, for how you get the answers that you type into WebAssign. Other questions? And we'll have time for more questions about this stuff on Wednesday. I actually didn't mean for us to go into quite so much detail today, but that's fine. It's good. Then you guys have time to think about it. And we will, on Wednesday, we'll do a little bit of review together, and then we'll say, okay, now we're going to do our practice test. We'll pretend like it's test day, and you guys will just get the password and you'll go out and do your practice test. I want you to try the problems on the practice test, but if you get them wrong, I'm still going to give you the full credit. Okay. It's going to be a completion grade for that day.
Is there a review assignment?
There's not a review assignment that is required for you to turn in. There is a review packet. I highly recommend doing that because then you'll basically have like all the work for the test sort of written out, like practice problems. So this review right here, I'm not going to collect that. Your points for review this time are going to be the points for doing the practice test together in class.
You should make the review extra credit.
Our math department has a policy, no extra credit. Sorry.
But aren't you the supervisor?
I'm not the boss. I'm only a medium boss. Any other questions?
Is the test review the same as the other ones? We have the answers on the back?
Yes, yes,
Okay.
yes, definitely. Okay, let's go ahead and look at some integrals for today. Oh, we're going to do our first participation question. You guys have all been asking good questions, and I have some that one of you sent me, which is good, but I had this one lined up already. This one's silly. They're all silly. So this is, there we go. These are 3 statements about me. your teacher, Mrs. Emsley. 2 of them are true and 1 of them is false. So I want everybody to guess which one you think is the lie. So in the chat box, you have to enter a number 1, a number 2, or a number 3 for your guess. Which one of these do you think is not true about me? And that'll be your first participation question.
Well,
Okay.
Wait, what was the question? Are we doing the same thing?
So no, these are 3 statements about me, and
Uh-huh.
one of them is false. One of them is a lie. You have to
Oh,
guess which one you think is false.
I was gonna write mine.
We got 6 answers, 2, 7 answers. Did everybody answer? 1, 2, 3, 4, 5, 6. Yes, everybody answered. Okay, drum roll. I know you guys are very excited to know. I think 2 people got it correct. This one is the lie. I have not hiked to the summit of Mount Rainier, but
yeah.
I have visited all 50 states. When my kids were little, we used to go on these crazy, yeah, I'll get to that, Josh. We used to go on these crazy driving vacations where we would get in our minivan with our tent and drive like thousands of miles, and we would just drive and camp and drive and camp. And we went to lots of national parks, and we have made it to all 50 states. Number 2, I have not hiked to the summit of Mount Rainier, although that is the kind of thing I would like to do. I have hiked to the bottom of the Grand Canyon, which was really, really hard, but you know, rewarding and cool to see. And number 3, yes, I did work for the CIA. It's like my one exciting life story that I have. So when I was in college, when I was about the age of all you guys, I thought I was going to study chemistry and be an eye doctor. And I changed my mind and I said, I want to study math instead, but I do not want to be a teacher. Funny, right? And so I went to the co-op office. Co-op is kind of like an internship kind of thing. And I said, I want to apply for jobs that take math majors. And I applied for several different jobs. And one of them was at the CIA. And I got an interview and I thought, well, it's a free trip to Washington, D.C., so I'll go on the interview, but I'm never going to do this. And I went out to Washington, D.C., and I had a polygraph, and I had a psychological evaluation, and I had a job interview. And then I came back home and thought, well, that was crazy and stressful. I'm never going back there again. And then I did get a job offer, and I thought, well, this is not something I can turn down. So starting in my junior year, I took a semester off and went and worked second semester of my junior year. And then I went back to school, and then I went back out and worked again. So I went back and forth between school and Washington, D.C. And I did that even all throughout grad school, the summer between my 2 years of graduate school. And so, yeah, I worked for the CIA. I spent half of my time working at the National Photographic Interpretation Center, which is in downtown DC at the Naval Yard. And there I worked on computer programs that analyze satellite imagery, which sounds more exciting than it is for your daily work, actually, because really I was just looking at computer code and doing tests to make sure the right numbers came out and stuff like that. And then my second half of my time with the CIA, I actually did work at headquarters, which was really neat because that's the scene you see in the movies. Like when you walk in and see the CIA, I worked there, and I spent time in a group that sort of analyzed countries and their economic development. And that's where I sort of moved away from computer science and into some statistics stuff. And anyway, that's that story. And yes, my husband worked there too, because guess what? That means your husband has been through a polygraph and a psychological evaluation. And so you know that he's a good guy. So that's kind of funny. I'm not the only person who ended up married to someone that I met when I was out there. So anyway, there you have it. CIA, long time ago, but it was fun to live out in DC.
Wow.
Okay, so time to do some really fun stuff and get to the calculus of the day. So before we do our new material, I just want to review. I know we did our review questions, but this is something that we covered a little bit ago. I want to make sure we remember. Talking about derivatives now, not integrals anymore. So we just want to remember our basic rules for taking the derivative of an exponential. Does anybody remember this first one right here? What's the derivative of e to the x?
This
1.
is
Not 1. It's almost that easy.
natural.
It's not natural log of x or x. Natural log is the inverse function.
E to the
L.
X
I heard it.
L.
It is just e to the x. That is the one function where the derivative is exactly the same as the original function.
Okay.
The only time, what's that?
This is 5.3, right?
This is going to be 5.3, yes, because we're going to talk about the integral of e to the x. So first, I wanted us to remember, and I'm going to go to my notes in a second, but we needed to remember this fact first, that the derivative of e to the x is e to the x. And then if we have not just e to the x, but like e to the 3x, remember it's still e to the 3x, but then we have to multiply by the derivative of the exponent, okay? So we need to remember that fact because now we're going to talk about the integrals of e to the x. And so not surprisingly, if the derivative of e to the x is e to the x, the integral of e to the x is also e to the x. Okay, so that's a fact right there. We have to memorize, we have to know the integral of e to the x is e to the x. Back again. So when we have a problem like this first example, remember that 2, it's a coefficient, there's no variable there, so we can just kind of ignore it. And then just think about what is the integral of e to the x. It is e to the x. Just don't forget, we still need the plus c at the end. And we don't really need that times sign in there, I just wrote that. Okay, and then for example, next one, same idea. We just integrate term by term. So the integral of e to the x is e to the x. But then what's the integral of that x? Well, then we have to go back to, not 1, you're thinking of derivatives. Remember, integrals, we're adding to that exponent. So it becomes x squared, and we multiply by the reciprocal. Don't forget that minus sign that's in between there. So there is our integral for that one. Okay, so when it's just a basic e to the x, pretty straightforward. Now what about, was there a question?
Oh, sorry.
No,
I was
no problem.
trying to take a picture of the where it said 5.3 because my pen's dying, so I'm trying to find some
Yes.
pen or something. Yeah, sorry.
Okay. Is that good? You got it definitely?
A quick picture and then sorry.
Yeah, go ahead.
Okay, I got it.
Okay,
sorry.
good. No problem. Okay, so it is a little different if we have a coefficient in there, okay? And this problem, even though, so I did tell you I told you one hint is you use substitution if there's only an x in one place. That doesn't actually always apply. That's just kind of one thing you can look for. Here we are going to actually do a little substitution because that exponent is a function. It's not just an x. Okay, so u to the 5x, u equals 5x. Take the derivative of that u. The derivative of 5x is just 5. And then move the dx over. So we're ready to substitute. This part, e to the 5x becomes e to the u. And then the only other thing we have is the dx. Oh, wait a second. We don't have just a dx here. We have a 5 dx. So we need to, we'll do it the multiplication way this time. Either divide by 5 or multiply both sides by 1/5. So we end up with 1/5 du equals dx. Now we can substitute in. Still have the squiggle because we haven't changed any exponents yet. Again, we can do a rewrite here. We can pull that 1/5 out front. And once we have it written like this, it's a super easy problem because we know the integral of e to the u is e to the u. And then we just need to put that 5x back in there. Okay, the way I worked this problem here, this is how you write out all the steps if you really want to see the math of what's going on behind this problem. But if you get kind of savvy with these problems, one thing you can do is you might just recognize and be able to think through your head. If I took the derivative here, like if, let's say you just are thinking through it and you're going to guess maybe that the integral of this, oops, the integral has to have an e to the 5x in it, okay? You might think about what happens if I take the derivative of this thing. Well, if I took the derivative of it, I would get 5e to the 5x because I need the derivative of that exponent. But I don't have a 5 up here in my answer, so I need that 1/5 in the front to get rid of it. If that made no sense to you, ignore it and just do this u substitution, okay? But if you start to see the pattern of what goes on here, if we were to take the derivative of this thing, we would get an extra 5 that's not here in our original problem. So we need that 1/5 to get rid of that 5. Okay, so if you see the shortcut, you can take it. If not, just write it out.
Does that work for all of them?
Excuse me, hold on. I'm gonna cough.
No, you're fine.
Pretty much.
You just have to kind of look and see it.
Yes, yes. It gets a little trickier when you have variables that are in there with your dx. When it's just something simple like this 5x, you can see it. When it's a little more involved, like the number 2 example that we did in warm-up, I think it's better to actually write it out explicitly.
Oh, yeah.
But on these kind of basic ones, definitely you can just kind of see this pattern.
Okay.
Yep. I kind of ran into my next problem there. Any other questions there?
So for this one, u is 5x.
Yes.
Okay.
Because we always look for a u that is sort of separated from the rest of the problem. And the way that 5x is separated is it's trapped up there in the exponent, okay? In the past, we've had things in parentheses or things under a square root sign, but being up in the exponent, that makes it a separate piece also. That's another way it can be sort of separated from the
And
problem.
then when we have to rewrite it, it becomes e to the power of u 1/5 du.
Right, because this came from what was originally blue, the e to the 5x became e to the u, and then the 1/5 du came right here.
Okay.
We replaced the dx with a 1/5 du.
All right.
Okay, let's do another one. I kind of wrote over the top of this. Hopefully you guys can still see there. We have e to the x squared. So again, that's going to give us a hint that maybe we want to do a substitution here. And if we take the derivative of that thing and move the dx over. Okay, once we have du isolated by itself, that's where we take a pause and we try to rewrite. So that e to the x squared becomes e to the u. So that took care of this. But we still need a dx to be replaced. And look, we didn't get a dx this time. We got a 2x dx. Now we could divide both sides by 2 to get rid of the 2, but you cannot do that to variables. You can only do that with constants. So there actually is no substitution that works here because we don't have x dx in our original problem. So this one is actually not possible. There are probably advanced integration techniques that I have forgotten since I learned them many, many years ago, but for the purposes of our class, that one is not possible. You're not going to see any not possibles on the test. I just wanted to show you that sometimes substitution doesn't work, and then we're just stuck. We can't calculate that integration.
So we won't get any problems like this on the test.
Nope, nope. The ones on the test will all be possible to either do direct integration or integration by substitution.
Okay.
Okay, next one. Here's another one. Now this, again, e to the x squared. So again, we want to say u equals x squared, but you'll see we have something a little different going on here, because when we take the derivative, we get 2x, move that dx over. Okay, and then let's take a look at what we can substitute. E to the x becomes e to the u, and 2x dx, oh, that's convenient. That matches exactly what we have here. So that means I replace that entire 2x dx with just a du, and that becomes a super simple problem. The integral of e to the u is e to the u, and then we just put that x squared back in there. And there is our final answer. Any questions on that one? Okay, so that's kind of the basics on integrals with exponentials. You can see sometimes they'll be very basic, like number 1 and number 2, and you just know that e to the x is still e to the x. Sometimes they'll involve a little bit of substitution, like number 3 and 5. Okay, so those are the kind of 2 types of problems that come from this section. Next up, we're going to look at integrals of logarithms, but before we do that, we're going to review our derivative of logarithm rules. Okay, we did these a while ago. Oh, I put the answer in. I meant to leave that blank and ask you guys if anybody remembers what the answer is, but I already filled it in for us. Okay, so just remember that the derivative of natural log of x is 1 over x. That means that when we go to integrate, when we move backwards, the integral of 1 over x is going to be natural log of x. Here's another derivative problem. Okay, so the derivative of natural log of x squared, we always take 1 over whatever's in the parentheses. But since that's not a plain old x, we do need to multiply by the derivative of the argument. So here we get 2x over x squared, which simplifies to just 2 over x. Again, that's not the topic today, but this is something we have done in the past. You will see on the test, and it's going to help us introduce the integral if we know the derivative formula. That's going to help us know the integral formula. Okay, so that leads us to this next rule. If you are ever asked to find the integral of 1 over x, it is the natural log of x. A couple things to notice. We need an absolute value here. The reason behind that is that you cannot take the log of a negative number. Okay, so we have to put absolute value around that argument, around whatever you had in your denominator. The other thing to notice here is, well, why do we need this rule at all? Can't we just rewrite this as x to the negative 1 dx and then apply our rules? Okay, well, if we applied our integral rules, we would add 1 to the exponent. So negative 1 plus 1 is 0. And then we'd multiply by the reciprocal of that exponent. And that means we are dividing by 0, not allowed. Can't do that, no go. Division by 0 is undefined. So this logically does not even work out to try our original integral rules. That's another one of the reasons we need this special rule for integrals with 1 over x. Okay, so let's look at problems. This first one, this is an algebra simplification that we've talked about before. You guys need to remember that this is equivalent to 4 times 1 over x dx. Whatever's in the numerator, You can always separate that out as a coefficient if you want to. And we want to write it like this because then we can apply our rule. It's going to be 4 times the natural log of x plus c. And again, that is just applying the rule we just learned right here in this section. That's just the memorization fact that we need to know. Okay, example number 2 in this section. Okay, before we do this one, we should simplify it a little bit. So 3x squared over x cubed, that does reduce. And once we reduce, then we can rewrite it just like we did in step 1. That's the integral of 3 times 1 over x dx. And once we have it written like that, the 3 just stays a 3 because it's a constant. 1 over x becomes the natural log of x. And don't forget, we still need that plus c at the end. Okay, so those are kind of the 2 basics when we just have a natural log in there. Next up, we're going to look at some where we need to use a little substitution. Okay, we did do one example like this, but we haven't seen many of these yet. But another way that an expression can be separate or can be considered an inside function is if it's in the denominator. So that's a possibility for our u. If we assign u to the denominator, then we take the derivative. The derivative of 2x is just 2. Derivative of -1 is 0. And then we move our dx to the other side. At that point, we have to pause and see what's going on here. So the rewrite here, be careful. This thing that we said was u, this thing right here, it's 1 over that value. So when we rewrite it, we're going to rewrite it as 1 over u. Okay, so this replaced this. U's in the bottom, so we got to keep it in the bottom. Now we also need to replace the dx. We don't have dx by itself right now, so I'm going to multiply both sides by 1/2. So that we do have 1/2 du equals dx. That's exactly what I need for my substitution, so I'm going to replace that dx with 1/2 du. And again, I like to get that coefficient just out of the way. So my integral is 1/2 times the natural log of u plus a constant. And then we just go back, make sure we bring our x's back in. And that would be our final answer. That's another one where if you can kind of think through it in your head, if you're thinking, well, what's the derivative of 2x minus 1? It would be 2. I don't have a 2 in there, so I need this 1/2. Again, if that doesn't make sense to you, just write it out. Questions about number 3?
So the only time we would actually have to put anything for like what u equals, would only be if we do substitution.
Say that again, Daffodil. The only time you need to put something in for u is what?
When you do substitution, like u
Yes,
equals,
yes,
okay.
yes. And we
I
need to
noticed
do...
that in 1 and 2 we didn't do that. So
Right, because on number 1 and number 2, we had just a plain old x in the denominator. It was not a function of x. It was just x by itself. It's
okay.
equivalent to when you need the chain rule in derivatives. Like if it's just the rule by itself, you don't need any substitution. But if it's something like here, we had not just an x in the denominator, but a 2x minus 1. So that's when we need the u equals. Yeah, here's another one where we're going to need u, number 4. I should have given myself a little more space in these. Let me add a little more space. So my writing's kind of crunching up together. 1 second. Okay. So for number 4, That one probably at first is kind of a stumper. Like we haven't seen anything that looks like that before. It's kind of a unusual looking problem. So I'm just going to go ahead and try, since I don't know what else to do, try u equals the denominator, because there's not any other tricks that work there. Take the derivative. 4 times 2 is 8x. Move the dx over to the other side. And then see what we have in terms of doing our substitution. Well, what we assigned for u is down there in the denominator. So again, when I plug it in, I need a 1 over u because I need it to stay in the denominator. That 4x squared minus 5 is in the denominator, so my u needs to be in the denominator. What I have left behind is x dx. Well, that's not what I have right here. I have an 8x dx. So I'm going to multiply both sides by 1/8 to move the 8 out of the way. And now I got it. Now I match. X dx is what I have. So in place of the x dx, I'm going to put a 1/8 and a du. Again, I just like to write my 1/8 separate. You don't have to write that step. And that means that the 1/8 just carries down. The 1 over u is natural log of u. And we always have plus the constant at the end. And then we get our x's back into the problem. Replace that u with its equivalent expression in terms of x. Questions? Okay, let's do another one. Now look at the difference between number 4 and number 5. Number 4, I said take the denominator and set it equal to u. So you might be tempted to try that with number 5 also. But there's a difference here. In number 5, we only have a single term in the denominator. Okay, so we want to try a simplification technique that we've used in other problems before we try to do any crazy u substitutions. And that is to go ahead and distribute this and divide it out. So no calculus here. This is equivalent to 4x to the 4th over x squared minus 3x squared over x squared minus x over x squared. I'm just doing some algebra to clean things up a little bit. Okay, once you've distributed it or split it into 3 separate terms, go ahead and do the simplification there. So that first term just becomes 4x squared. The second one, the x squareds cancel, and we just get minus 3. And then on the last one, the x cancels, but we still have an x in the denominator. Okay, now that we've done some algebra to simplify it, now we don't need anything too fancy to do the integral. We can just integrate this term by term. So 4x squared, we want x to the 1 greater power, and then multiply by the reciprocal. We have our minus 3 when there's no x and we want to bring x to the 1 greater power. It's just a plain old x in there. And then we have to recognize and remember, here's our new rule. The integral of 1 over x is the natural log of x. Just a little bit of simplifying we can do in that first term. 4 times 1/3 is 4/3. And that would be our final answer. So what we did up here at the top is simplify with algebra first. Questions? Okay. we do. I'm just scrolling to see what else I have. Okay, this is our last problem, I think. Okay, before our last problem, we will have our second participation question. And this was one of our suggestions from somebody in the class. If you won the lottery, what's the first thing you would do? That one takes a little thought. If you won the lottery, what is the first thing you can, and you know, I would say, don't make it too serious, make it something fun. I mean, we could all maybe try to cure coronavirus. That would be a good thing. But let's think of more fun and exciting things. What's one thing you would treat yourself to? Josh, what's AMG? Buy a house for mom and pops. Nice. Oh, that's good. You guys are very responsible. Good. Buy a house. Oh, a Mercedes. Nice. I'll take one of those because right now I drive a minivan. I'm with Josh. I'm going to buy a Mercedes. Quit school for a year and travel and then go to Vegas. Very good. Very good. Yeah, I think my two would be, I would definitely buy myself a new car because like I said, Honda minivan is where I am right now. And then travel would be my other thing too. Travel for merit. Good. Good, good. Well, we can all cross our fingers, but you know, this is a math class, so I am legally obligated to tell you that the probability that you win the lottery is basically 0. So, you know, I don't know what we're going to do about that. We're all out of luck, I guess. Okay, so here's our last question from this section. We could also have word problems from this section, and here's an example of a word problem you might see on WebAssign or on a test. Well, test is in WebAssign too, on your homework or on a test. And in this example, they give us the rate of change for the revenue of a company, and that's the equation there at the top. Remember, that means that is a derivative. They've given us the derivative. And they're telling us that that R stands for revenue in billions of dollars. The T stands for time in years. And notice that T equals 0 corresponds to the year 2004. So for part A, oh, and in 2009, the revenue was 21.7 billion. Part A, find a model for the revenue R. So they want us to, when they say find a model, they mean find an equation. So they're asking us to find an equation for R. And so this goes back to section 5.1, remembering when they give us a derivative, in order to find the original function or the equation, we are going to take the integral. So we want to find R equals some equation, and the way we are going to do that is we are going to take the integral of this derivative that they gave us. I put a dt at the end because t is the variable we have in this equation this time. Okay, so let's apply our integration rules that we have learned all about in these last 3 sections. 2.2, when we integrate it, becomes 2.2x. Sorry, not x, t. The variable in this problem is t. I've been doing a lot of x's lately. And then that negative 5.6 over t, I could rewrite that as 2 separate pieces, but do we know what that would look like now that we've practiced? The 5.6 stays. And then basically we have 1 over t, and the integral of 1 over t is the natural log of t. And then we have plus a constant at the end. Okay, we're not done with part A yet, but any questions there in that step? Okay, so now when they ask you to find a model, that automatically means we need to figure out what C is. We can't just leave it like that. That's not our answer, okay? So that's where we're going to use this piece of information right here. What they've given us is in 2009, the revenue was 21.7 billion. So that means for T equals 9, because that's the year 2009, since 4 is 2004, that means 2009 is T equals 9. For T equals 9, the revenue is 21.7. So we want to plug these 2 values into the equation we have right now to figure out what C is. Okay, so we'll put in the 21.7 over here in place of the R. And we put 2.2 times 9 minus 5.6 natural log of 9 plus C. I did keep those absolute value symbols Technically, in this problem, we don't need them because we're not going to be talking about negative values for time. Okay, since 9 is a positive number, you can basically ignore those absolute value symbols. Okay, so I want you guys to try this on your calculator. Make sure you can do this. You're going to plug this whole thing into your calculator and then move it to the other side through subtraction to figure out what C is. Go ahead and try that one. I'll give you just a few seconds to try it, and then I'll give you the answer so you can see if you match. Give me that C to 2 decimal places. Looks good, Nadia. That's what I got too. Everybody see if that's what you get for your C. If not, maybe try it on your calculator again, or if you want me to, I can pull up the calculator and we can take a look at it together. Okay, now our final answer, we're not done yet. We have all the information what we need, but part A asked us to find a model for R, so we need to write out that final equation. R would be 2.2 times T minus 5.6 times the natural log of T plus 14.20. This one in particular, I would count correct if you had the absolute value signs or if you didn't, just because time is always going to be a positive number in this case. Okay, so that's our answer for part A. Any questions about part A? Okay, then part B, find the revenue for 2011. So they are asking us to use the answer we found in part A and plug in the value we need to find the revenue for 2011. So for the year 2011, that would mean T equals 11. So this just becomes a calculator problem. 2.2 times 11 minus 5.6 natural log of 11 plus 14.20. I would again go ahead and do 2 decimal places for this one and then think about what the label would be. Give that one a try. Okay, yep, we get a couple people. You should be getting 24.97. Keep in mind, that's not $24.97. It said in the original problem, we were measuring our revenue in billions of dollars. We're a big company. So that'd be $24.97 billion. One of the nice things about a test on WebAssign is you don't have to worry. I can't make you write the units because they usually give it to you. They usually put, like, they'll leave you a blank and put a $sign in front of it. So you don't have to think quite so much about your units. One little benefit. Okay, that is all I have for today. Don't forget your worksheet packet number 3 and your current WebAssign sections. If you feel like you are good to go, you are welcome to leave the meeting, and I will see you on Wednesday. I will stick around for anybody who has any questions. Have a good day, guys.
Thank you.
Thank you.
Thank you.